Now let's take a look at the Wavetable engine. So I'm going to click over here and switch from analog to wavetable. So the interface here has changed, and you notice that the tune and unison section is pretty much the same. There is one minor difference. Switching back to analog, you'll notice that the drift parameter is no longer available in wavetable mode. Alright, so what exactly is wavetable synthesis? It's a relatively newer synthesis technique, at least compared to the analog synthesis technique. So the idea here is we're not restricted to certain basic geometrical shapes like we get in the analog domain. So in any analog synthesizer, these are the main waveforms that you will encounter. But in the wavetable world, or let's say the modern digital world, you can get a variety of different shapes. Right now we're looking at this particular wavetable in two-dimensional mode. It'll make a lot more sense when I click on 3D mode, because here we can now see the actual table. So this is a wavetable. Within this wavetable, we have 4 different waveforms stored. Now, ironically, this particular basic waveforms wavetable has these classic geometric shapes. But what's interesting is that I can gradually morph from one position to another and interpolate between the different shapes. Let's switch to a 2D view to see this a bit better. So you can see how the shapes are kind of gradually interpolating from one to another. And you can't do that in the analog domain. You either get one or the other. Now this is happening because morph is on. If I turn off morph, now we get those basic shapes and it just snaps between those shapes. Now like I said, we're not stuck with just these 4 shapes. If I click on basic waveforms here, we have a pretty huge collection of different wavetables. Let's check out some from Pigments 3. How about Code Morph? Now clicking on it once will load the wavetable even though we don't see it yet. You can hear that as I'm playing a note, and I can even adjust the wavetable position. Let's say I'm not too happy with that, I want to try a different one. How about this Duotronic? And let's say I do like that, I can double click it, and now that window disappears, and we can look at the interface. Now this wavetable is a lot more complex, and there's a lot more positions in between. So even though the morph button is off, it sounds pretty smooth. So it really depends on the wavetable you select. If it has fewer individual frames, you will need that morph button to gradually morph between them. But if it has a lot more, you may not need that. You can also import your own custom wavetables here. So I can just load in one of these that I loaded in earlier. It's actually a kick drum. So now Pigments has transformed that audio waveform into a wavetable. Now it doesn't sound anything like a kick drum. Just imagine this to be the very first frame of that kick drum sample recording. And Pigments has selected different positions within that recording to use as different waveforms. If I turn on morph, we could get a smoother result as we're transitioning from one to another. Alright, let's go back and load in some of the factory wavetables. I'm going to load in Callisto. Alright, now let's talk about this bottom section here. So we have a modulator very similar to the analog mode, where we have this modulation option. But in this analog mode, we were essentially using oscillator 3 or the noise generator as a modulator to modulate oscillator 1 or oscillator 2. In wavetable, we're using a separate modulator that's completely independent from the main wavetable to modulate either the frequency, the phase distortion, or this wavefolding. Alright, so let's see how this works. Now before we even do any kind of modulation with this modulator, we can even just listen to it. I can bring the volume down on the wavetable. As long as the volume of the entire Wavetable engine is up, we can hear the modulator here. And as you can see, it's just a sine wave. We have all these different shapes, including noise, tuning control, fine-tune control, and semitones. Now tuning, there are a couple of different options. There's this relative mode, which means that the tuning is in relation to the tuning of the oscillator. And then there's absolute mode, where it's independent of the oscillator tuning. And then lastly, there's Hertz mode, where we're setting the frequency of the modulator in Hertz. So right now it's set at 1640 Hertz. And if I play different notes on the keyboard, you'll notice that it does not track the keyboard. It's fixed at this frequency. Alright, I'll go back to relative mode. I'll bring the volume down. And now let's hear it modulating this wavetable. Let's start with frequency modulation. So this is going to be audio rate frequency modulation because our modulator is running at audio rate. So let's have a listen to this. We're currently in linear mode. I should probably also increase the level of the wavetable so we can actually hear the wavetable. There we go. Alright, now let's bring in some linear FM. Pretty intense. Let's switch to 2D mode. So as you can see now, we can visualize the processing. So sometimes 3D mode might look better to understand what a wavetable is, but in 2D mode, we get to see a bit more details of what's happening, at least in terms of modulation. Now let's switch this to a basic waveform so we can really understand what's going on. I'll go back to this basic sine wave. So we get a pretty harmonic sound in this linear FM mode, but what if I switch out from linear to exponential? Let's have a listen to this. It sounds a little inharmonic, and one glaring difference is that as I'm increasing the FM amount here, the pitch is changing. Whereas in linear mode, there is no such pitch change. So for most of the time, you may want to be in linear mode, but if you like that pitch change to create interesting effects, you can choose exponential mode. And that's exactly what we get in the analog domain. When we're doing any kind of analog style frequency modulation, it's usually exponential FM. Alright, next is phase modulation. Again, keep in mind, this modulator is modulating the phase of this wavetable. Now, phase modulation sounds very much like frequency modulation, specifically linear frequency modulation. So let's find out. Sounds and looks pretty similar. Most of the time in the digital domain, synthesizers tend to use phase modulation instead of frequency modulation to achieve that frequency modulation effect. So phase modulation means adjusting the phase or the position of the waveform at audio rate. Alright, next let's check out phase distortion. Now this is a bit different. So we can hear phase distortion by itself by increasing this amount knob here. So phase distortion was a synthesis technique pioneered by Casio, back when Yamaha was selling FM synths, and Yamaha had the patent on FM synthesis, so no other company could utilize that technique. Casio came up with phase distortion, which was a different technique, but resulted in a sound very similar to FM synthesis. Now here what's happening is that this sine wave is changing kinda into a sawtooth-like waveform. And there is no frequency modulation or any kind of modulation involved here. So what's happening here is that this waveform is being played back, but at a different rate, based on these target shapes. So in this Q shape, what's happening is that the engine reads through the first part of the wavetable really quickly, and then reads through the rest of it kind of slowly, and then speeds up again towards the end, basically following this Q shape. In the end, it's still the same 440 cycles per second if you're playing middle A, or 261 Hz if you're playing middle C approximately. But the result is change in tonality. So let's hear that again. Let's try one of the different shapes here. How about this round mode? Pretty interesting. This changes the sine wave into more like a square wave, introducing odd-only harmonics. So that is phase distortion. Very interesting synthesis technique by itself. Alright, so let's say I want to modulate this phase distortion amount at audio rate. That's when I'm going to use this knob. Now it sounds a bit more subdued because the amount is already down. Let's leave the amount somewhere in the middle and now try it again. Still kind of subdued, but you can clearly hear there is some change in tonality. Now if you want a more drastic effect, the best way to get that is by changing the tuning of the modulator itself. So if I go in here and set this to a different value and then try again, listen to that. A lot of interesting things you can get when changing up the tuning of the modulator. Alright, so that's phase distortion. Lastly, we have wavefolding. And this is technically also distortion because we're basically distorting the waveform. So let's get rid of this here and let's just listen to wavefolding. And again, without any audio rate modulation, let's just listen to wavefolding. So this is a unique kind of distortion technique where when the signal crosses above the peak point, it kind of folds back into itself. And that's where you get those multiple bends. There are different shaping algorithms here. So there's number 2. Let's try number 3 here. A bit more aggressive. And again, if I want this wavefolding amount knob to be modulated at audio rate, I can bring this up. For more aggression, let's change the tuning. Now keep in mind, you're not stuck with just using one of these 4 modes. You can have all 4 running simultaneously. And that's a huge difference compared to that pure sine wave that we were using. So as you can see, plenty of sound design options just within this Wavetable engine. So I hope this was helpful. Maybe spend some time playing around with these parameters before moving on to the next tutorial, where I'm going to talk about the next engine, which is the sample engine.